Alright, so let's talk about the Stanworth rules for glass formation. So basically, glass are composed of main components like silica or borium oxide or other oxides of metals like titanium, aluminium, and etc. So, and in most cases, these main components are mixed with other chemicals like sodium carbonate, like Na2CO3, calcium carbonate, in order to give the glass a low melting point and also add stability to the glass. So Stanworth proposed some guidelines that should be followed when forming a glass. So let's look at these guidelines. So the first guideline is that cation valence should be greater than 3. So recall that we said that the main components of most glasses are silica or borium oxide. So if we try to break this into charges, we're going to have B3 plus and then O2 minus, right? So the cation valence is definitely up to 3. So looking at this also, we have Si 4 plus and O2 minus. So the cation valence is greater than 3. So they obey the rule here. So let's say these both obey. So looking at the second point, decreasing cation size. So this has to be obtained by experiment, but the point here is that the cation size must be low, right? So looking at the third point, cation electronegativity between 1.5 and 2.1. So it's important to note that their cation electronegativity should be between these values. So now let's look at this question. Use the Stanworth rule to propose the applicability of this metal and this as glass former. So let's break it in. Let's put it this way: M2O3 and M2O. So let's look at the first rule there. So the first rule states that the cation valence should be greater than or equal to 3. So let's break this into charge. We have this and then we have this. So this also we have this to be plus. This is 4 plus and this is 2 minus. So basically the two obey the first rule there. The cation valence should be greater than or equal to 3. So both of them have a cation valence that is up to 3, right? So let's look at the second point there. So a decreasing cation size, right? So looking at this cation size, we're given from the value here that the cation size is in Armstrong. So we have the value here. So the cation size for the first one is 0.2 Armstrong. For the other is 1.16 Armstrong. So let's put this on top. So the rule says that decreasing cation size. So the cation size here is lower than this. So this should be more applicable in glass formation than this. Looking at the second point. So let's look at the third point, right? So the third point says that the cation electronegativity should be between 1.5 and 2.1. So the electronegativity value for this is 2.04, which falls within the value, right? It falls within the value. So this is correct, right? And for the other one here, the value does not fall within the range. So this is out. So basically we could see, let's put it this way. So we could see that this is more applicable. So we can write it more applicable for glass formation. So than the other oxide here. So that's the answer.